Assalamualaikum warahmatullahi wabarakatuh. Hi everyone. Today I'm going to explain about Norton's and Thevenin's theorem. But before I start, I want to introduce myself first. I'm Muhammad Afin. I'm from Muhammadiyah University of Surakarta. I'm studying electrical engineering and I'm from class I. Let's get started. The first thing I want to tell you is value of A and B. Here A is equal to the last digit of my name. Last digit of my name is 5, so we got A equals 5. And the value of B is the second last digit of my name. And the second last digit of my name is 0. And according to the rules, if any of these value is 0, we must add 1. So we add the value of B here by 1, so the value of B equals 1. And take a look here. The resistor 1 is equal to 2 plus A, and we got A is 5, so 2 plus 5 equals 7, so the resistor 1 is 7 ohm. Resistor 2, 1 plus B. We got B here is 1, so 1 plus 1 equals 2. The resistor 2 is 2 ohms. Resistor 3 is equal to B, and we got B here is 1, so the resistor 3 is 1 ohm, and the resistor 4 is 4 ohms. And we got two questions here from the circuit. We must determine the Norton and the Thevenin circuit connected by a resistor R4. And the second problem is we must determine the current flowing in resistor R4 using Norton's theorem. Let's get straight to the steps of Norton's theorem. Step 1 is we remove resistor R4. We remove R4 here, and we mark these two holding terminals as A and B. Step 2, connect A and B. We connect the A and B here, then remove R3 because it's in parallel with A and B. We remove it, we remove the R3. And then IN is therefore the same as I through R2. IN here is the same as I through R2. The third step is finding the IN by applying the formula of current divider rule. Take a look here. IN is equal to IR2, so the formula is R1 times IS divided by R1 plus R2. Here we got R1 is 7 and IS is 5, and the R1 plus R2 is 2 plus 5, so we got 35 divided by 9, and it is about 3.8 ampere. Fourth step, finding the Rn. In order to finding the Rn, we must set the Is here to 0, and we remove it. So the circuit is only like this. Take a look here. So the R1 is in series with R2, and these two is in parallel with R3. So the formula becomes like this: R1 plus R2 because it's in parallel, and in parallel with R3. So we got R1 is 7 and R2 is 2. 2 plus 7 plus 2 is 9, and in parallel with 1 here is equal to here. 9 times 1 divided by 9 plus 1. We got 9 divided by 10, and it is 0.9 ohm. There we have it. We got IN and the RN. And in order to finding the Thevenin circuit, we got IN is 3.8 ampere in the last calculation, and the RN is 0.9 ohm in the last calculation. So in order to find the phi Thevenin and the R Thevenin, apply the formula. Phi Thevenin here is equal to IN times RN, and the R Thevenin is the same as Rn. Therefore, the Thevenin is In times Rn, 3.8 times 0.9. We got 3.42 volt, and the R Thevenin is the same as Rn. So we got 0.9 ohm. And the circuit comes like this. This is the Norton circuit, and this is the Thevenin circuit. There we have it. Problem number 1 solved. Let's get straight to problem number 2. In problem number 2, we must find current through R4 using Norton's theorem. So here's the simulation of the Proteus. We got 0.88 ampere, and the manual calculation, the formula is Rn times In divided by Rn plus R4. Take a look here. The Rn times In is equal to phi, and Rn plus R4 is our total. So substitute the value. We got Rn is 0.9 and In is 30.8, and the Rn plus R4 is 0.9 plus 3. The result of this calculation is about 0.8769, and if we read this as significant figures, so we got a 0.88 ampere, and it is the same as the simulation of the Proteus. There we have it. Problem number 2 solved. So yeah, thanks. Assalamualaikum warahmatullahi wabarakatuh.